Welcome to the Tech Mechanic. Quick heads up. This Netflix case study is part of our Solution Architecture Master series. We've already covered these core concepts in detail using real-world examples. If you are new here, I highly recommend watching the playlist from the start. Every lesson builds on the previous one, creating a structured roadmap. That said, let's dive right in. Imagine it's Friday night. You grab some popcorn, open Netflix, and press play on your favorite movie. The video starts almost instantly. No buffering, no waiting. But behind that single click, thousands of servers across the world work together in just a few milliseconds. Today, we are going on a journey through Netflix's entire architecture and discovering how it serves more than 300 million users without crashing. Here's our journey today. We'll follow one Netflix request from the moment you open the app until your movie starts playing. Along the way, we'll revisit many concepts we've already learned, including authentication, API gateway, microservices, Kafka, Redis, CDN, recommendation engine, observability, and much more. By the end of this video, you'll understand how all these architectural building blocks work together. Seeing this infrastructure in action reveals how Netflix seamlessly handles millions of concurrent streams without breaking a sweat. It is the ultimate real-world blueprint for modern cloud-native engineering. The first thing Netflix checks is your identity. Instead of asking for your password every time, your app sends a secure authentication token. Netflix verifies the token and confirms who you are. This is the same JWT concept we learned in our previous videos. The request doesn't directly contact dozens of services. Instead, it first reaches the API gateway. The gateway authenticates the request, applies rate limiting, routes traffic to the correct microservice, and records logs and metrics. Think of it as the receptionist of Netflix. Netflix isn't one giant application. It's made up of hundreds of microservices. Each service has one responsibility. One handles your profile, another stores watch history, another processes subscriptions, another manages recommendations, and another streams videos. This architecture allows Netflix teams to develop and deploy services independently. When you search for a movie, Netflix doesn't use a traditional relational database. Instead, it uses a powerful search engine that can instantly find movies even if you misspell the title. This is exactly why we learned Elasticsearch earlier. Netflix doesn't simply display popular movies. It analyzes your viewing history, ratings, genres, watch time, and even what similar users enjoy. AI-powered recommendation engines personalize your home screen so that every user sees different content. Imagine millions of people watching the same blockbuster at the same time. Instead of repeatedly querying databases, Netflix stores frequently accessed information in Redis. This dramatically reduces response times and database load. Here's where the magic happens. Netflix doesn't stream videos directly from one central data center. Instead, it uses content delivery networks. The movie is delivered from the server closest to your location, reducing latency and preventing buffering. Every click generates an event. Starting a movie, pausing playback, completing an episode, or adding content to my list, all of these events are published through Kafka or Azure Event Hubs. Different services consume these events independently without slowing down the user experience. Netflix collects billions of viewing events every day. These events flow into massive data lakes where analytics platforms identify trends, popular shows, regional preferences, and user behavior. These insights guide future business decisions and content investments. If a movie suddenly stops playing, engineers need to find the root cause quickly. Netflix uses observability tools that combine logs, metrics, and distributed tracing to pinpoint exactly which service is causing the problem. One of Netflix's greatest strengths is resilience. If one microservice fails, the entire platform doesn't go offline. Instead, other services continue working, graceful fallbacks are applied, and users experience minimal disruption. Behind every request, Netflix protects user data using secure authentication tokens, role-based access control, encrypted communication, and centralized secrets management. Security is built into every layer of the architecture. This is the complete Netflix architecture. A user's request first reaches the nearest CDN for fast content delivery, then passes through a load balancer and API gateway. The gateway authenticates the user and routes the request to the appropriate microservice, such as search, profile, billing, or streaming. Search requests use Elasticsearch, recommendations are generated by AI, frequently accessed data is served from Redis, and permanent data is stored in databases. Every important event is published to Kafka, allowing analytics, monitoring, notifications, and audit systems to work independently without affecting the user's experience. Across the entire architecture, security is enforced using JWT, OAuth, RBAC, secrets management, and HTTPS, while observability tools continuously collect logs, metrics, and traces to keep Netflix reliable for millions of users worldwide. In the next case study, we'll explore Amazon architecture case study and see how the world's largest e-commerce platform handles billions of searches, orders, payments, and deliveries every day. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the TheTechMechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.